idea what's going on. But we'll continue and just pretend for the moment that things worked. And we'll get them up to the dev team to see what's going on. So what it's done, or what it's done behind the scenes, is it has run an RNA-seq processing workflow. And we developed this in collaboration with someone who actually does RNA-seq analyses. The reason for that is there's a lot of stuff that we're working on, and we're not experts in everything. So we rely on collaborators. And so when it came to this RNA-seq processing pipeline, we developed it based on work that James Schnabel did. He came down for a week. We got his pipeline integrated. And if you click on this, it'll go ahead and give you a breakdown of everything that it's going to do to your data sets. We try to make it one-click simple. This is not going to be perfect. It's not going to be as good as what a handcrafted expert can produce for you. But you know, sometimes you just shop at Target because it does what you need it to do. Gets you most of the way there. And so, but what we want to make sure is that we document, that we're giving you all the details for what it was that happened. This is the 80% solution. Solution for the rest of us. And based on people's feedback, we do modify our pipelines. Because people need different options exposed, we make sure to expose them. Or we eventually put it on our work chart to do so. But we try to keep it as simple as possible. So once it's finished, what it has done is it's taken your reads, mapped them to the genome. It then quantitates the takes your reads, cleans them, maps them to the genome, quantitates it per position along the genome, and then quantitates it per transcript if you have a genome that has been annotated with transcripts. It then takes all of those data sets, loads them and bundles them together inside of the notebook, which you can see right here. So we have 3 data sets. We've got our transcript measurements, our mapped reads, and a read depth per position. This is just a BAM file. You then can use this, add some metadata, modify the information associated with this. But I do want to show that what it's done is it's automatically tagged this notebook and each one of these experiments with the processing pipeline that it used. So the other thing is that once these data are integrated, then you can instantly use our genome browser, which is based on JBrowse, to visualize these data. Now, since I mapped it to a Arabidopsis, this is going to take a few moments to load. The reason being is that Arabidopsis right now has 1,300 functional experiments mapped against it. And so what it's doing right now, and we realize that this is a little bit of a bottleneck, is it's running through, and there's a lot of private data. And for every private data set, it has to check my credentials to see whether or not I have permission. Then it grabs all of those experiments and loads them into a table over here that I then can use to navigate and search through all of those data sets. So here's those experiments. I'm going to go ahead and turn on the features. And so this will generate for us our track. This is using CoGe's way of visualizing genomic features with the dashed line separating your top strand and your bottom strand, and these overlaid arrows representing different parts of a gene. If you like the traditional GBrowse way of doing it, of just boring, flat, unexciting arrows, you can do that too. We like our 3-dimensional tubes much, much, much more. And then, so what we have down here is this notebook. Test in glass, live, dangerous. Obviously, it was very dangerous. And if I open this notebook, here are the 3 experiments. I'm going to now visualize each one of these separately in its own track. So when you have things bundled together, it will draw all of those within the same track. And if you want to, you can go ahead and have them drawn separately on individual tracks. So here's our FPKMs. Here's the individual reads shown from the BAM file that have been mapped to the genome. And then down here are the read depths per position. So I'm going to assume you guys know what these little things are. These are individual reads. I'm just going to shut this track off for the time being just so we can focus on the other ones. And actually, I'll turn the BAM back on, but I'll make sure it's at the bottom. And so now what we can do is we can zoom along and scroll go along, we can zoom in and we can zoom out. So I'm going to go ahead and zoom in just on this region right here so we can look at this in a little bit more detail.
And so this will just put all the chromosomes in across the whole browser?
No, so this is just visualizing chromosome 1.
Oh, okay.
This is just typical JBrowse. If you're not familiar with it,